with F, but then I didn't understand.
Let me see if I can find a comparable. So was it a problem on this here? They give you a graph and they ask you these questions?
Yeah.
Okay.
This is they want to touch it.
Oh, that's fine. They don't have to touch.
Okay.
I like it. All right. So I have a few ideas in section 12.1 I need to talk about still. Let's see. Anybody live downtown excited about the All-Star game? And how it's going to impact your life? No? Anybody going to the All-Star game by any chance?
The security's pretty tight down there, though.
Yeah, it sucks, man. I wanted to make some trouble, but they won't let me in. All right. Yeah, I don't blame them, man, with everything's happening recently. Shit. Okay, so there's the question is... Oh, shit, that's right. This is the magic book. So I can do this. That's good. Yeah. Freeze. Okay. Analysis of just nails. I like that. That's good. All right. So, the very first question, f of g of 0, and I just kind of gave it away, right? There's a better way to write that. Now, immediately write that better way. F of g of 0. So what do you have to figure out first then? What g of 0 is. And that's going back to an earlier skill we developed. If I'm given the graph, somebody's already done all the work. Which graph is g? Red. So what's g of 0?
-1.
Beautiful. When x is 0, the red line is at -1, so g of 0 is -1. So now the question says, what's f of g of 0? G of 0 is -1. So the question is, what's f of -1? Because g of 0 is -1. So you replace g of 0. So if I said, what is f of 2 plus 3? What am I really asking? What is f of 5? Okay. So this is saying, what's f of g of 0? But we know g of 0 is -1. Because that's where g is when x is 0. G is at -1. The output is -1. Is everybody cool with that first step?
So f is 0?
Well, what's f of -1?
0.
Which line is the f line?
Parabola.
The parabola, the blue one. So when x is -1, where's the parabola at?
It's at -1.
No, the red line is at 0, but where's the blue line when x is -1? What's the output?
2.
2. So f of -1 is 2. So f of g of 0 is 2. So that's a two-step process, which should make sense. It's got an inside and an outside. I got to do the inside first, and then I can do the outside. That's equals 2 by the way. Okay. Does that make sense? So look at part B. What would you have to figure out very first thing?
F of 1.
What's f of 1? Okay, so what is f of 1?
2.
2. I like it. So then now what's the question? What's g of 2? So what's g of 2? 2. No. Is it? No. Which one's g?
Y.
And so what's g of 2? Well, where's the red line and when x is 2?
-1.
-3. So there's a couple layers to this problem. Make sure you're looking at the right function. Number one, that's throughout the whole problem. You got to be looking at the right function. And number two, you got to realize how to even evaluate this kind of thing in the first place. I do the inside first, like we've done forever. Please excuse my dumbass son. We do in the parentheses first, right? Or do you answer? All right, cool. Is that cool? So that's the same problem we've done, just in a slightly different format. But it's the same problem. I still got to figure out the inside first.
No, I was thinking about the G and G then.
Oh, yeah. Oh, so like the last one says f of f. All that means is I'm never going to look at which one. I'm never going to look at the red line. Never. Because it's all about f. So what's f of negative 1? Oh, 2. Yeah, f of negative 1 is 2. Alright. I'm only looking at the blue line now, right? Because that's what f is. So f of negative 1 is 2. And now I'm looking, what's f of 2?
Negative 1.
Negative 1. I like it. So that's all it means. Don't freak out just because it keeps using the same letter. It just means you're not going to look at the other graph. That's all. You're not going to use the other function at all. Maybe. Yes, sir.
I got another question.
Sure.
Number 8, number 12.
Number 8.
Number 12.
All right.
Number,
I'm not going to put this one up here.
number 28.
So I want this to become second nature, really. Cooperate. Okay. Dr. Hoover. So we talked about this yesterday, but I want this just on the surface of it to make sense. What would g of g inverse of 2? Do you know what g is? No, but the fact that I wrote this means it is a function that has an inverse. So I know a lot about it just by somebody writing this down. But now, how the hell do I answer this question when I don't know what g is? What is the answer?
Negative 2.
The answer is 2. Because what do these do? Yes. Just like if I said, what's the cube root of 2 cubed? 2. Right? Or alternately, what's the cube root of 2 cubed? 2. Because no matter how you write it, they're going to kill each other. That's what they do. So this is a specific example of this general idea. But no matter what the function is, if I apply its opposite to it, they will cancel each other. So f wants to do something to 7, and it does it to it. What does it become? It almost doesn't matter if I immediately undo what I just did. So it was 7, it became something else. This is going to make it become 7 again. It's going to undo what was done. So that's why these kill each other. 7, for example. I like it. Okay. 12?
Yeah.
Oh, yeah. So remember, let me see if you guys can do. If I had a graph that looked like this, can you draw on the air what its inverse would look like? Quite.
The right one.
Yeah. It would look like this. Right? Because it's got to be symmetric around what line? Y equals x. Remember, we've done a few of these. When I do an inverse, it's always got to flip around to y equals x. No, yes, yes, no? And that makes sense for a couple reasons. We switch x and y, so in a sense that kind of makes sense it would flip over. All right, so if it goes to the point negative 2, 1, now it's going to go through the point 1, negative 2, right? So that, when you do a few points, you can see why it makes sense. It does end up flipping around the y equals x line. Okay, so is that by itself cool? I mean, that's the answer to that question. What is it? Where's the axis of symmetry for inverse functions related to each other? It's always y equals x line, and that has to do with the fact that we switch x and y to find them. Okay, maybe. What was that? I was going to say something else. Oh, so what's really neat? Just to hijack this session. What does that look like? Well, let's figure this out. How do I figure out what that looks like? I'll kick ass. When you get an old school teacher like me, do a table. So you know I want it done by hand. All right? What can I not use?
0.
I can't use 0. So something weird's going to happen at 0. So I can use like -1, -2, right? So what do I get when I plug a -1 in? And what about -2? -1/2. What about when I plug a 1 in? Get 1. What about 2? Now here's something that you might not think about. But what about when I put a 1/2 in? What do I get? 2. Because what does this function really do? It flips it, whatever it is. It's like the reciprocal function, right? So when I plug a 1/2 in, what's 1 divided by 1/2? Yeah, 1 divided by 1/2. 1 times 2 is 2. Kick ass. Right? So that's 2. So what about if I put -1/2? -2. That's crazy. So what would this thing look like? So now I've got, you can do it, Jeff. Let's see. 1, 2, 3. 1, 2, 3. 1, 2, 3. Jeff, you can count. So at -1, -1, -2, -1/2, but also -1/2, -2. So it ends up looking like this. Become big. This has an asymptote because I can't. What's the only way to make a fraction 0? If the top is 0. But what's the top here always? So it can never be 0. So that's why there's an asymptote here. Why is there an asymptote here? Because x can't be 0. Right? Do you guys get the idea? So very often asymptotes come from what can't happen. I have to run up against that. It's like, I always think about star. It's a trap. Turn around. No? Yes? Yes? Maybe? It was just a bad joke. I'm sorry. So then 1, 1. So now this side is going to look very symmetric to this. 2, 1/2, which is going to be all the positives. 1/2, 2. So it's going to do this. Now, do you see how that's already symmetric to the y equals x? So what's this guy's inverse going to be? It's going to be itself. It is its own inverse. So if this is the flip it over function, x is 2, it makes it become 1/2. X is 1/2, it makes it become 2. How do you undo a flip? You flip again. So it's its own inverse. And how do I find this guy's inverse? So this is a beautiful review. If I'm given this, how do I find its inverse? And then you solve. So I can multiply it by y. Is that cool? And then I
Divide by x.
So I get f inverse is 1 over x, which is what it was to begin with. If you think about it, that only makes sense. How do I undo, if somebody flips my number over, I just flip it over again and I undid what they did. So there are some functions who are their own inverse. What does that mean visually? They're already symmetric to this line. So then when you flip them, they flip right on top of themselves, right? This would be a good example of that. This function is y equals -1 over x. It is its own inverse because it would flip, when it flips right back on top of itself. All right. Get an early start on the mind blowing. It's kind of neat, maybe. Okay, so it's not impossible for a function to be its own inverse. It has to already be symmetric to this line. Then it's going to fold right on top of itself. Okay, enough of that. Okay,
So the axis of symmetry doesn't change?
For inverses, when I'm comparing two inverse functions, the axis of symmetry between them will always be this. Always.
Always be this way?
Always. Always.
So even on that one over there, it's the same way?
Yes, always.
Not in the middle of it?
No, can't be. Can't be. So when I'm comparing two inverse functions, they have to be symmetric with respect to this. Always.
Oh, which is 1, 1, 2, 2, 3, 3.
Beautiful.
1, 1,
Beautiful.
1, 1.
Exactly. Because those would be all the points that don't go anywhere. And all the other points would flip on the other side of it. Exactly. That's why it makes sense. Thank you, Nathan. I always need help with figuring out how to say something. Some of you guys are like, I still don't get it, but I'll figure it out. Okay. What was the other thing I left out? Oh, 28, yeah, let's see, 28.
I just wanted to check my answers. I think I'm right.
Oh, okay. So sort of like the problem we had up here just a minute ago. they could give me a problem where they don't give me the graph, they give me the table of values, which is the same thing as giving me the graph. Because a table is a collection of points, and a graph is a collection of points. So it's the same problem. The extra level of difficulty on this problem is they threw in some inverse questions, right? So very quickly, this is f of x. Here's g of x. Pick the book up, Jeff. There you go, buddy. I hate when they do this. Okay. Alright, so that's what F does and that's what G does. And this is number 23 through 28. So this is number 28 specifically, but they all use the same values. So 28a says,
F of g of x to the negative 1,
yeah, F
or the inverse of g of
of
x,
G inverse of
1.
1. Alright, first thing I want you to do, take like a millisecond and rewrite that in a better form.
F of g of x, F of g negative, or F of the inverse of g.
So we're gonna, the cool thing is, the one good thing about this is it's like the first letter of the word of. So F of G inverse of 1. I like it. That's a much better notation than the fog notation, right? I'll take that as a, we agree. I don't know yet. Let's find out. I don't know. Actually, I do know if I just look at my magic book, but I won't. So the very first thing I got to figure out is what? No?
Inverse of G1.
G inverse of 1. Do I have a table for G inverse? Can I make one very easily? Yes. Why is it so easy to make a table for G inverse?
You just flip them.
Yeah, just flip 0, negative 2, 1, negative 1, negative 1, 0, 2, 1, negative 2, 2. So now what's G inverse of 1? Negative 1. So then it's asking you what's f of
Negative 1.
negative 1?
Is 1.
1. All right, done. So the trick there is, do you see how that's the same thing as the graph? It's just actually a little bit easier because I can just see the number instead of having to find it on the visual. But still, it's the exact same work. Just if they have any of these in there, make its table. And then it's just looking at that table. Yeah.
So I can't just use the opposite of.
You could do this in your head and just, when it says G inverse of 1, look here and then look there for the output. But this is just making it a little bit more obvious. Yeah. Okay, maybe.
So the g of f, inverse of f.
Yeah, you can make like an F inverse table, or who could tell me what F inverse of 0 is?
0.
0. What's F inverse of negative 1? 1. Because what's an inverse do? It takes all the outputs back to what the inputs were. That's how, if I wanted to make an F inverse table, I would just turn all of these. Some of you guys might realize that Nathan said, why would I do that silly crap? If you say F inverse of 2, I'm going to look there, and that's my output. Because the inverse looks at it backwards, right? But what's F of 2?
Negative 2.
What's F inverse of 2? Negative 2, yeah. Okay, maybe.
So the inverse of negative 2 of f of the inverse of f of negative 2 is 2.
Yes. Cool.
And then the g of 2
Negative 2. I like
is
it.
negative 2. Now, how do you know where? So, how do you know which x or y column to go to first, as far as?
If they say F of 3 or something, I'm going to look here, of course, right? If they say G of something, I'm going to look here. If they say F inverse, I'm going to have to look at the reverse of these, right?
But you always look at the x as far as compared to the first one. You don't look at the y.
So,
I think he's talking about over there, how it's f of g minus 1.
well, so if I said what's G of 1, this means what letter? X, period. Now, if I push it a little bit, you guys might realize that if I said what's G inverse of 1, what letter does that mean? Y. Because what's an inverse do? It takes all the outputs, and gives you back the input. So,
Because they have an f of x, they don't have a y. So,
oh yeah. So, well, I put f of x there, so my bad. I just put y there for myself.
yeah, I like that better.
Sure, okay. And there's g of x, and then this would be g inverse of x. I like it. Remember, f of x is interchangeable with y. All right, but we use f of x so everybody knows when I say f of 7, you know which function to look at.
So the answer to B is -2.
So if I remember correctly, that sounds right. Yeah. Yes. All right. Let me see.
23.
Yeah, there it is. Okay. Which one? Sorry.
23.
So that's using the same data. So if I said what's f of g of 0, the first thing is I write this as f of g of 0, so it makes a little more sense. So what's the first thing I need to figure out?
G of 0.
What's g of 0? Well, what is g of 0?
It is -1.
-1. So now I replace this with what it is. And now I see it's really asking me what's f of -1. 1. Done. Yeah. So when you first look at that, it might look like, how the hell? But then you start to realize they've done all the work for me. I don't want them to tell me what f and g are, because they've done all the work for me already. I don't want to look at those. I can just look at the answers. Kick ass. And I don't know if any of you guys picked up something weird about this. The easiest function that is its own inverse. Who thinks they know? What's the easiest function that's its own inverse? I love that question.
Y equals x.
Y equals x. The y equals x line, what happens when I flip it over the y equals x line? It stays on top of itself. Right? X equals y, which is the same thing. The other easiest one would be y equals -x, because when I flip that over, it's right back on top of itself. Right? How do you undo changing the sign? You change the sign again. Right? So it's its own inverse. How do you undo doing nothing? You do nothing again. Yay. So that's why y equals x is its own inverse. All right. Okay, maybe. When I teach, I have a lot of levels of explaining. Some of it you don't have to really totally understand to be able to do the work. But if you really want to understand what the hell you're doing, it's good to hear it. I don't know. All right. You didn't have to say all that, Jeff. I know. Let's see. Oh, so here's the last thing I didn't talk about. So I've said a few times something like, if the function has an inverse, if it's invertible. So now let's take a second to figure out, when would a function be invertible? On one level, that's a stupid question, because if you focus too much on, I take any function and I just flip it over the y equals x line, like I've said happens, then like everything could be, I could flip everything. Nah. The trick though is, what do I know about it if I write this? You don't even know what it is, but what do you know about it? What do you know about this thing? It is a function. That means it passes the,
Line test.
which one? Vertical. The only one we know so far, but we're going to learn another one today.
Okay.
When I write this, that is also implying that this new function is itself a function. So think about this. So remember, I'm flipping around this line here, right? So what if I have, is this a function? Is that a function? Yes, it is. It totally is. Right? Is that cool? Of course it's a function, because it passes the vertical. Now, if I flip it, do you guys see how that would become this? Is that a function? Let me stop right there. Is everybody cool with that? If I flip it around this line, doesn't it become that? You guys cool with that? No? No, you don't see that? No, really? Okay. All right, let's give this some points real quick. Let's see.
Yeah, that's positive, negative, and then the negative.
So here's -2, 1, let's say right there, right? And this is, let's say this is -1, 3. This is -2, 1, and then this would be negative 3, 3. So then the inverse would have to go through what? So this goes through negative 3, 3, negative 1, 3, and negative 2, 1. So the inverse has to go through
3, negative 3.
3, negative 3,
Negative 1, 3.
negative
I'm sorry, 1, negative 3.
3, negative 3, 3, negative 1, and 1, negative 2. I'm doing the same as again. So the inverse, so here's the function. What will the inverse have to go through? Flip them. Yeah, it's easier if you actually show yourself what you're doing. So it has to go through 3, negative 3, 3, negative 1, and 1, negative 2. All right. Now, are you guys cool with that? And you see how this would flip? See how it's got to be mirrored this way. If you turn your head like this, perfect. Well, I wouldn't say perfect. Jeff drawing perfect mirror image of each other. All right, I like it. When it gets all wavy, the inverse is a little harder to see, but that's true. Is that a function? No. No. So I would have to say that this has no inverse. It has no inverse function. It has an inverse relation all day, but it has no inverse function. All right, you guys with me so far? Because its possible inverse doesn't pass the vertical line test. So screw this shit. Let's do something better. Because was that easy? I had to make up points and shit to do that, and you guys were like, I don't think that's the inverse, and I don't blame you too much because you're not used to looking at it. So it'd be much better to say, instead of flipping it and then checking it with a vertical line test, why don't we flip the test and not flip the function? So I'm going to use the horizontal line test. So it's got to pass if it passes the vertical line test, it is a function, right? Function, check. If it passes the horizontal line test, not only is it a function, it has an inverse. So I officially call it invertible. Become an E. There you go. So an inverse exists. I like it. Now let's really analyze. Yes, sir.
If, like, say there's a parabola that isn't a function, that doesn't pass the vertical line test, if you put the inverse of it, would it become a function?
If I start with something's not a function, I wouldn't even talk about its inverse. Because there's no point to it. It already isn't a function. Now, that doesn't mean that this doesn't have some use.
Yeah.
We just don't call that this guy's inverse.
Okay.
Now, real quick. All right. Which way we want to go with this? Yeah, I'll say this. Is everybody cool with this?
Yeah.
This beautiful, ugly thing. Let me just take that away. I'll forever record it. Oh well. Here's a normal parabola. Weehaw. You would hope it's inverse, and that's y equals x squared, right? We know its inverse is related to what? What's the opposite of squaring something?
Square root.
Square rooting something, right? The opposite of cubing something is cube rooting something, exactly. You just put the word root after you're fine, right? Fourth power, fourth root. Fifth power, fifth root. But if I tried to invert this, wouldn't this happen like this? So that's why what we do is we talk about the principal square root. Now you really see why we talk about the principal square root. Because if I say this means the positive root, I took that away. I really want you to understand. Remember, how many roots does 9 have? Square roots. It's got 2. 3 and negative 3. But what is the square root of 9? 3. It's defined to be the positive root. So I took away the negative shit. Is this a function? Yes. By taking away the negative shit, I made this have an inverse. I just say the inverse doesn't use any negative outputs. You guys kind of see what I'm saying? So I have to restrict this guy's domain. I actually have to say it only works for greater than 0, and then the inverse would be the square root. You guys kind of see what I'm saying? You don't have to fully understand that because it's a little further than I have to go, but still. That explains why we have a thing called the principal square root, because then it is an inverse. It passes the vertical line test. All right, maybe. Okay, all right. That was a little too far. Okay. Coming back to this, Oh, that's right. That's why I should have done that first. Remember we just had this year? What was it? -2, 1, -1, 3, right? And -3, 3. Okay. So I said this the other day, but just to make sure you understand why this name makes sense. Why is this a function? Because every input... Oh shit, what's the definition of function? Every input has only one output. I love it. That's what makes it a function. So if I said, 1 second ago, where was I? 3 feet up in the air, right? It makes physical sense. It's got one thing it can tell me. Think about the inverse function has to be the opposite of that. It means for every y, there can be only one x. But if I said, okay, I'm 3 feet up in the air, how long ago was it? Can you give me one answer? When was I 3 feet up in the air? 1 second ago? And 3 seconds ago. Shit! So this is why we call an invertible. This is not invertible, right? Not